everyone. This is Jeremy Wei at ProphetStor. Let me introduce ourselves first. And the company was founded in 6 years ago, dedicated to artificial intelligence for IT operation. Our goal is to improve the IT operation by providing the predictions for the IT infrastructure underlying components and build the correlation with the upper layers. So we currently deeply working with the SAF as well, and contribute the digital value prediction technology to SAF. The main distribution will be currently is under test by the community. Should be ready by the Q3, and we can accurately predict the component failure error and intervenes, so to avoid any unexpected instance and provide a recommendation for the IT managers for the maintenance or replacement. So the safe usage for uses technology for the data migration, automation of data migration, and redirect the traffic to the second copy, so that we can increase the reliability SLA. So if you're interested, we can have the separate talk. But now I think that we talking about what we are doing with the OpenShift. So so I hand it over to my colleague, Brian.
Hi, I'm Brian. I'm the Chief Data Scientist of ProphetStor. Today I'm going to introduce Federated Die for OpenShift. Of course, Federated Die it includes an AI engine that based on our patented AI technology. It basically provides 4 types of machine learning features. The first one is performance prediction and the resource planning. So we know that the characteristic of container operation is very dynamic. So it is very important to understand what is going on in the future and not just depends on the current metrics to decide when to add new paths or deploy pod on different nodes. So performance prediction and resource planning is very important for efficient container operation. And we also focus on what we call cross-layer performance issue troubleshooting, because we know that even user understand that how our containers work, there are still a lot of situations that problems occurred in the underlying layers. That means the infrastructure, maybe the hardware component such as hard disk, hard drive, flash drive, or memory, or even CPU cache. And we use machine learning to predict when the disk is going to fail, and also correlate those hardware issues to the performance issue in the upper layer. That means the container layer, or the virtualization layer, or even the most top layer, the application layer. And the third machine learning feature we provide is what we call impact prediction. We know that since we can predict, since Federated Die predict the hardware issues that are going to happen in the future, so user would like to know how those possible failure is going to impact the upper layer. That includes impact to the container, or the storage, or the persistent volume of the container, or even the application running inside the container. And the last piece is what today I'm going to talk is the container operation automation. Since we all have the information of the 3 machine learning feature I just mentioned, that is performance prediction, cross-layer performance issue troubleshooting, and hardware and impact prediction. So based on this information, our Federated Die will help to decide when and where to scale out paths to different nodes or to scale up to have more resources or to scale down. And this is the big framework of FigureDAI for OpenShift. From left to right is the observation. That means FigureDAI collect information from OpenShift / Kubernetes, and also the containers and the nodes. And the information FigureDAI collect include the performance matrix, events, logs, and also a smart. I mean, this is smart. That because FigureDAI predict the disk failure, so we base on smart data to predict when the disk is going to fail. After FigureDAI have all this information, and we conduct FigureDAI conduct a performance anomaly detection based on a deep neural network, and hardware issue prediction is also based on deep neural network, basically a time series deep neural network algorithm. And then we also use a machine learning to tell user if a system operates correctly. That not only about the hardware issue, also the OS level issues. And the last one is the work we are working on, that we use natural language processing to understand the log content and event content, and then we correlate those log and anomalies of within log and events to knowledge base to help IT administrators to fast conclude what's the root cause from the knowledge base and the solution that the possible solutions that may apply to the issue they are facing. And the actions that user can take include the cross-layer issue troubleshooting. In FigureDAI, we put cross-layer aspect as our core value of AIOps, because we think that when IT administrator want to troubleshoot an issue, just looking at the application performance issue is not enough. They also want to know when an application has a performance issue or what the root cause. They not only take a look at the configuration application, they also need to know the underlying objects such as the containers and even the hardware components. And also, yes. And the action provided by FigureDAI is not only for OpenShift to automate the operation of containers. We also provide AI-assisted actionable items for support staff or engineer staff, and try to find a solution from the knowledge base. And this is more detail about how our FigureDAI work for OpenShift. In this slide, you can see that the yellow block are the paths of FigureDAI. We collect, just as I said, we collect information from OpenShift and specifically Prometheus, and then use this collected information to generate a prediction. And then we use a Kubernetes operator to configure the scheduler and descheduler and autoscaler. But I think the most prominent difference of our prediction of our container operation is it is based on prediction information, not just the current metrics. This is very important because we know that container operation is very dynamic. So it's better to know what is going on in the short term future and then mid-term future. And so the scheduler and autoscaler can know better the decision of where to allocate paths and or even to add more replication set to pass, or even add more nodes to a Kubernetes cluster. Okay, sorry, since we are going to run out of time, so I need to skip some of the slides. And this is the metrics that of the data sources and what we can do from these data sources. Mostly for the performance metrics and this smart, we use a recurrent neural network to generate the performance prediction and the display prediction. And for unstructured data that include the log event, knowledge-based configuration, we use natural language processing to provide something such as discrepancy trending prediction from log event and memory error detection prediction from log event, and even the misconfiguration of the config file by using NLP. And our final goal is to have an NLP to provide AI-assisted solution guidance for engineer, IT administrator, and the support team. I will skip this one, and this is the feasibility study. What we are doing right now for OpenShift for SAP. Just Jeremy has just mentioned, we are working with the SAP community to provide this failure prediction for SAP, because we know that when the OSD disk fail is a large probability prediction. And we started our container study even before the version 1 of Kubernetes. So we already developed machine learning pattern for container 3 years ago, and also we have reinforcement learning. So I don't have time to talk much about how to apply reinforcement learning to improve our accuracy rate, but we use this to improve our accuracy rate when we train the model. And this is a screenshot that we deployed the Redeye on OpenShift. And this is the component, microservice component running inside OpenShift, including dashboard, our AI engine, and serious database, streaming database, such as that. And then this is the actual screenshot of the Redeye. It provides a cross-layer.
Excuse me, I have to leave the meeting and leave the Brian 2 more minutes here. I'm sorry. Okay. Thank you, Diane. Thank you.
Okay. And this screenshot is about what we call time machine. Because we know that when IT administrator want to troubleshoot an issue, they need to look back what's going on in their IT environment. So Redeye provide what we call time machine to let user to reverse back to what's going on in their IT environment, and provide a cross layer map to let the user see how an event that may impact to other components in their environment. And since we also provide the prediction, so its time machine can also move to the future to let people see, to let IT administrator to see, for example, when the disk is going to fail, how this failure might impact other virtual machine containers or paths such as that. And this is the screenshot that specifically provide the information about the disk failure prediction. And then this is a capacity prediction, CPU state prediction, disk performance prediction. And this is a screenshot of the disk failure prediction. And currently, our disk failure prediction algorithm can provide very high accuracy rate for hard disk, and somehow lower accuracy rate for SAS disk we know that SATA disk doesn't have abundant small attribute as SATA disk. And we also tell user the possible symptom of going to fail disk, and we also provide a recommended replace time based on the performance prediction. Okay, that in summary, we use our FigureDie learn the performance patterns and detect anomaly from the historical metrics, logs, and events. And based on the performance, we use some Kubernetes mechanism such as scheduler and horizontal autoscaler, vertical scalar to provide the container operation automation. And also we are working on FigureDie on OpenShift, and we expect the enterprise-ready feature provided by OpenShift can help FigureDie to deliver enterprise-ready ALPS platform for enterprise and data centers. And our future work include we will put more focus on natural language processing, because we consider that, for example, we try to transform the anomaly we detect in performance, maybe in time series correlation, into natural language, and then use natural language to search a solution from a knowledge base, from a discussion forum, such as that. And the things we have a lot of data need to train, and we are also working to test how to use Kubeflow for distributed training. And that is.
Well, Brian, thank you for doing this and compressing it in such a short amount of time. I really appreciate it. This is something, and AIOps is one of the many topics that we talk about a lot inside of OpenShift, with OpenShift dedicated and online, and with a lot of our customers. So I know that it's going to be of interest to a lot of people to see what you're doing, and hopefully we can bring you back for a deeper dive and talk about this with some of the folks that are looking into this on the OpenShift side of things too. Really nice. And apologies to all. I really tried to get too many topics into today's meeting. And so next time, maybe only 2 at each event. And if you have questions, please do reach out to Brian. This is really good material, Brian, and it's very interesting to see how the whole AIOps space is developing, and what you're doing is really cool. So thank you again. Anyone have any questions for Brian? The last few moments of this waning meeting?